Trigonometry is to do with ratios in similar right-angled triangles. To use trigonometry, we have to learn a new way of labeling the sides of a right-angled triangle. So here are three right-angled triangles. The last one's not drawn very well. We know we can label the hypotenuse. That is the side opposite the right angle, and the hypotenuse is the longest side. So far, we've only labelled the other sides A and B, the shorter sides. And that's because we need another piece of information to label the two short sides. We need to know where they are compared to one of the other angles in the triangle. So the hypotenuse is always opposite the right angle. We need another angle marked to label the other two sides. And in most questions there'll be an angle marked in some way. It might be marked with this sign here. This is called theta, and it just means the angle. It's used often like X for when we don't know what an angle is. The angle might be marked just with a symbol, as we've got here in the second triangle, or the angle might be marked with its size in degrees, like in the third triangle. But for whatever reason, to label the two other sides, we have to have a particular angle that we're going from. If two angles are marked, you'll have to choose one. Now the two short sides of a triangle, the first one is called the opposite, and it's opposite the angle that's marked. So not opposite the right angle, that's the hypotenuse. Opposite, so not touching the angle, is the opposite side. So we go from the angle in the second triangle to the side opposite. From the angle in the third triangle to the only side that's not touching it, the opposite. The other short side is called the adjacent. Adjacent means next to. And the adjacent is the short side that is touching the angle that we care about. So in our first triangle, here it is. In our second triangle, the side touching that angle, and in the third triangle, it's up here. So we've got our hypotenuse, which we already know. The opposite and the adjacent. And we can abbreviate them H, O, and A. So we need to be able to label these sides. Now the next thing we know, or need to know, to study trigonometry, is that there's a relationship in any triangle between the side length and the angle size. We already know that the biggest side is opposite the biggest angle. The smallest side is opposite the smallest angle. And that makes sense if you think about it. Look at this triangle that I've drawn down here. Here's my angle, and if I suddenly made any of the sides bigger, like this side, that would change the size of the angle. If I wanted to keep that as a triangle, I make that side bigger again, it changes the size of the angle. bigger again changes the size of the angle. If I made any of the other sides longer, this one for example, if I kept the angle the same, I'd have to change all the sides, and if I only changed one side, the angle would change. So every time you change any side length on a triangle, the angles change, unless you change all the side lengths to keep your triangles similar. See, I'm making every side in this one longer at the same time, and I'm just getting a big pattern of overlapping similar triangles. And that brings me, now we need to remember that there's a relationship between side length and angles. That brings me to similar triangles. Here are three similar triangles. Let's label their sides. You'll see I've got an angle marked in each one. Start always with the hypotenuse. Opposite the right angle. Opposite the right angle. And in this last one, opposite the right angle. Once you've got the hypotenuse, label the opposite. Opposite the angle that we care about. In all three triangles. We can label it opposite if we're starting to get confused. And the adjacent next to the angle that we care about in all three triangles. Have a look at what happens in each triangle if we calculate the opposite over the adjacent. In the first triangle, our opposite is 3, divided by our adjacent, which is 4. I've got 0.75. Check it for the next one. Opposite over adjacent. Opposite is 6, divided by the adjacent, which is 8. 0.75. And the last triangle, opposite over adjacent. The opposite is 4.5, divided by the adjacent, which is 6. 0.75 again. The relationship between the opposite and the adjacent is always the same for identical triangles. We know that since these are, for similar triangles, we know since these are similar triangles that each of those angles must be equal, and equal angles in right-angled triangles have equal ratios when we do opposite divided by adjacent. We can do the same thing with the other pairs of sides. We could also do, say, opposite compared to the hypotenuse. Or we could do the adjacent and the hypotenuse. There's 3 pairs of sides. And all the time we'll find that in similar triangles, so they've got the same angles, those ratios of pairs of sides will be the same. If I changed the size of the angle, remember what we discovered before, the length of the sides changes, as I just did here in the large one, and so the ratio would change as well. That means that it's only that particular angle there, whatever that happens to be, that has this particular ratio from the opposite over the adjacent of 0.75. And every single angle that we could have in there between 0 and 89.9 degrees, we can't go up to 90, every single angle has its own particular opposite over adjacent ratio. And the whole key to trigonometry is that those ratios are written down for every single angle. If we know what the ratio is, we can find out the angle. And if we know what the angle is, we can find out the ratio. And if we know the ratio between two sides, we can find unknown sides. So we'll learn how to do that in future. The whole key to this video is firstly learning opposite, adjacent, and hypotenuse. And secondly, learning that we're looking at ratios of sides in right-angled triangles. We'll learn how to find sides and angles next video.